Okay. Welcome to Computer Science OCR, and we are going to start our new chapter today, as we have done this chapter that's called chapter number 1. It's done. The last topic we have done is errors. Remember?
Yeah.
Yeah. So we have successfully completed this topic. So now I'm moving back to the topic, the syllabus. First, we need to see the syllabus again, and then we are going to start the new chapter. Is that okay? Hello?
Yeah.
Oh, yes. Okay, so this is your OCR J277 computer science syllabus, right? Okay. Now, we are going to see our content, what topic we have done till now. Let me check in your recording lessons. We are taking lessons from the November. Since November, we have done pseudo course. Chapter programming is done. That's your paper number 2, algorithms is done. Right? Can you open your notebook so you can tell me much better that what we have done? We have done algorithms 2.1. We have done programming fundamentals, and we have just done our robust programs. These 3 topics are done. Can you confirm to me this?
Yes.
Yes, great. Okay, so let me see. Logic, yes. Boolean logic is also done. You didn't tell me that. Boolean logic is also done, because I'm discovering your lessons, binary search, logic gates. On 6th January, we have done expressions. And then January is gone. In January, okay, on 13 Jan, we have started robust, great, and we have done robust as well. So these 4 topics are done. Is that okay?
Okay.
Okay, so I'm starting 2.5. I also wanted to announce the test next Saturday. We have topic 2.1, we have topic 2.2, and we have topic 2.3 test. Is that okay?
Yeah.
TEST test, not Boolean logic. So only the topics on which I have make a circle. Is that okay?
Yeah, that's good.
Great. I'm sharing a picture. Syllabus status. Okay, 2.1 till 2.3. Test on Saturday. Okay, now we are going to start with the topic 2.5, right?
Yeah.
That's called programming languages and IDEs. One more thing I would like to ask, in your school, look, Boolean logic, have you done this topic? Look, and or not?
Yeah. Yeah. Yeah.
Great. Okay, I'm sending you some worksheets of this later on, okay? Okay, this is our new topic, right? Okay, I'm asking you, do you have a Python programming in your school, or which programming? Yeah?
Yeah, Python.
Okay. Do you have any resources, any manuals which is given your teacher to you?
No, she tells us how to do it in the
Yeah. Do you have anything?
like a book anything.
Yes, any book, any notes provided by the teacher to you for the Python programs?
Then
Yeah, please. Now, we are going to start our chapter number 2.5, Programming Languages and Integrated Development Environment. Languages. What is language? Language is a medium of communication. Like I'm speaking up with you in an English language and you are able to understand me, isn't it?
yeah.
What other languages you understand? Urdu?
Yeah.
Great. So this is the language. Just like we humans uses a language like Urdu, like English. Computers have their own language. Do you know about that language? That language is
Um,
called binary or machine language. This is the language of computer, isn't it?
yeah.
What is the language of computer? Binary or machine code.
Machinery.
So you can see this is the language of computer. Can you understand what is it written here?
Yeah, I can understand you.
You understand it? Tell me what is the meaning of it. That's great. You understand machine language.
Huh? For the
You didn't understand. This is a machine language. Humans are not able to understand this code. You said, sir, I am able to read it. Yes, you can read it. Even I can read. But I'm not saying that. I'm saying, do you understand what is the meaning of this word? This number. You said no. Because we humans are not able to understand binary language. This is called binary language. Is that okay?
yeah.
That's great. So look, this is a computer. This computer is called ENIAC. ENIAC, the Electronic Numerical Integrator and Computer. And it is a first used computer in 1945. ENIAC. So these computers are purely working on binary languages, right?
Yeah.
What's the name of this computer?
Working on binary language.
ENIAC. The name of this computer is?
Any
What is the full form of ENIAC? Electronic Numerical
numerical
Integrator
integration.
Computer. It was invented in 1945. Understand?
Yeah.
Great. Let's move on. So we are talking about the languages. There are the two types of languages. Can you name them? The two types.
The
One language type.
low level and high level.
Yes, low level and high level. What is high level language? High level language is a language of humans, and low level language is a language of computer. So let's see about the low level language. Machine code is a low level language. This means that it can run directly by the processor with no translation needed. Of course, computer does not need any translator because the data, the language is already in computer's mother tongue, binary. Are you getting it?
Yeah.
So there is no need for computer to translate. It has little or no abstract. Each instruction deals directly with the computer's hardware, and so a machine code programmer would need to understand the inner working and hardware structure of the processor. Yes, the computer uses the low-level language. It means that computer doesn't need any translation. And that language, the low-level language, the machine language, is going to control the computer directly, either the hardware of the computer or the machine code. So the programmer who is using the computer needs to understand the language, but computer itself doesn't need it. The programmer would need to specify each of these steps. Like if the computer adding two numbers, look. So would take numerous steps to load data into the registers, performing the additions and store the answer. So the programmer need to understand what is going on, how computer do this thing, how the computer performing the steps. So low-level programs are also hardware dependent. They will not run on a different type of computer, as the machine code instructions for that computer are likely to be different. You use consoles like Xbox, PS5, and there are many other consoles. Basically, that consoles are the computer, and they are independent consoles. You cannot say that Xbox is connected with the PC or PS5 connected with the PC. No, personal computer is a different machine. Consoles are the different. So they are designed for different purpose. So that is the purpose of the low-level languages as well. Low-level languages are the languages of computers, binary, and they are going to be designed different types of hardware according to the need. You cannot match all the computers with each other, like satellite. Can you match satellite with your computer, with your PC? No. Satellite is another type of a hardware. So satellite have a different types of coding. Maybe any low-level languages there. Got it?
Yeah.
Okay.
Yeah, got it.
Great. One simple way to make low-level programming language slightly easier is to replace the binary machine code instruction with the short mnemonics. Yes. Now, I can ask you that, did you understand this pattern? You say, sir, I don't understand what you have written. This is a binary language. Yes. Now we are applying a code called mnemonics. What? A mnemonics. M-N-E-M-O-N-I-C-S, mnemonics. So mnemonics are the codes which are going to convert the binary language into a short code like ADD. Look, this is an English language now. ADD. ST. LDD. Many codes are there. That codes are called mnemonic codes. So, such as replacing this 0010011 with ADD. This language is known as assembly language. So the mnemonic codes are also called assembly language, right? Mnemonic codes are also called assembly language. Understand?
Yeah.
Can you tell me again about the low-level language and how it is difficult?
The numbers, they turn into numerics. They convert the binary code.
Yes. So can we understand low-level language? No, we
No.
cannot understand low-level language. So how do we understand it?
By converting
Converting what? Converting what? Converting it into mnemonic code.
into
And mnemonic codes are also called codes.
assembly.
Right. So, and a programmer called assembler would convert the mnemonic back into their binary equivalent. Yes. So there is a translator called assembler. The translator name is assembler. Assembler is going to convert what? The mnemonic codes again into the binary code. So assembly language is converted with the help of assembler, and it converts the mnemonic code again into the binary code. I hope you understand this logic. Look. So assembler is a translator which converts the mnemonic code into binary code, right?
Yeah.
Now, I'm giving you some time. What you have to write down? You need to write down the types of language heading first, these 2 points. Then you need to write down low-level language. and note down the important points, whatever you understand in my lesson. And please write down the chapter name. What is the chapter name? 2.5, programming languages. Is that okay?
Yeah.
Great. The screen is on.
Language.
Look, the low-level language is also called
Low-level language. It's also called
machine,
machine code.
right? Okay. It is understandable
Only by computers.
by computers. It uses binary pattern to convert data.
Into mnemonics.
Yes, low-level language uses mnemonic codes. Mnemonic codes.
To convert binary into English.
ADD, LDA, STO, etc. to convert data into binary. Okay. Okay. It uses assembler to convert data from mnemonic to binary again, right?
Yeah.
So this is a summary of our lesson. Okay, now we are moving to the new topic. What is that topic? High level languages, right?
Yeah.
Oh, that's great. Okay. So I'm moving you back on the chapter. So languages like Python, Java are the examples of high-level language. There are many different high-level languages, each with their own specific use. For example, PHP, JavaScript are used to create web applications, whereas Visual Basic is commonly used to create desktop applications. I think you heard these names, isn't it?
Yeah.
As PHP, Java, Visual Basic. So all in all, high-level language is a language of humans, and it is in a form of English language, isn't it? So this is a snippet here. You can see a very easy code. You assign a value x10 and y20. Can you tell me the total x plus y? What is the meaning?
You can't add together.
What is the answer?
X, Y.
Sorry? The answer is
X, Y.
x plus y. What is the answer? Put the
X
value
plus Y.
30. Total is 30. Look, x is here.
Oh.
Yeah, you didn't got it. And look, 20. So we add 20 plus 10 because look, x and y. These are the variables, and the variables are assigned by the values 10 and 20. So if you write x plus y, what does it mean? You're adding the values, not the variables. So what is the values recited? 10 and 20. So what is the total? 30. Is that okay?
Yeah.
So programs written in a high-level language uses English-like syntax with the keywords such as while or if. This means they are much easier for the programmer to use, and errors can be spotted much more easily. What do you think? Is it right?
Yeah.
So what do you think? Is it easy to find errors? Yes, it is.
Yeah. Yes, it is.
It's English language because it is English syntax language. So anyone who knows and understands English can easily search the errors in it and find out the error and make the good program, isn't it?
Yeah.
That is the reason we teach you the high-level languages like Python. I'm not going to teach you a machine code language. Why? Because it's no use. There's no need of it. The basic thing. So high-level languages also use abstraction to hide away details of underlying processor operations. What do you mean by abstraction? I teach you this topic, abstraction. What is abstraction?
Abstraction is
Yeah. Remember the two maps? I teach you two maps. One map on the left, one map on the right. And I teach you which one is easier to understand. You said, sir, the map on the right-hand side is easier. I ask you why. You said, because in that map, I easily understand the map. Look,
the easy way of understanding a program.
yes, okay. Read this definition, abstraction. It's here. Look,
Removing unnecessary detail. The programmer of high-level language
did you
does not.
remember? I think I need to
No,
memorize. Just a second. Just a second. No need to worry. I'm here for you, my dear. Look, now you have to remember. Look, which map is easier for you to understand?
the right one.
Why?
It's easier to
Because there is nothing difficult things in it. So we make the map easy. That's called abstraction. Abstraction means what? To remove the unnecessary things. So right here in our lesson, in a program, in a high level language, we also use abstraction. Now tell me, what is the meaning of abstraction in programming?
the way details.
Exactly. So in a high level language, we use what? Abstraction. Why? We make the code simple. We make the program simple. We don't want anything confusing in the program. So we delete it, hide unnecessary things. Is that okay?
Yeah.
So in a high level language actually requires a processor to do three things. Yes, your processor, your computer processor have to perform three things. What? Load the first value into the accumulator, add the second value to the 2, and store the result. Okay, so what we are doing here, you have to see here in the bottom of the page.
Hmm.
Can you read this line for me? X is equals to 1 plus 2. Are you able to read
Yeah.
it?
Nah, can you go down a bit?
Yeah, it's here. It's here. Look, I make an arrow for you. X is equals to, yeah.
X equals 1
Yes,
plus 2.
this is our code, right? Okay, now, so high level language, how to perform this? Look, it first load the value 1 into the accumulator. What is accumulator? Any idea? What is accumulator? Accumulator is a register which stores only arithmetic data. Did you understand? What is accumulator?
A register which stores only arithmetic
Register.
data.
Exactly. So whatever the calculation we perform, where did it stores? It always stores in
Accumulate.
perfect. And then the second value plus 2 will be stored in the accumulator, and then you have to total them. That's it. So in this way, the programs are written in a high level language, cannot be executed directly by the processor. They first must be translated into machine code, and the processor takes the time to carry out. Yes, whatever the instructions you're doing, like you write x is equals to 1 plus 2. This whole instruction first translated into what? Into machine, into what? Machine code. Look, into binary. And then computer processor is able to understand. And then computer is able to process and produce output. Got it?
Yeah.
Okay, now what you have to do, you need to write the points on the high level language. Okay, there we go. Look. Your time starts now.